Welcome friends. Let us continue to study IC engine on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topic included in today's lecture is equations to solve numerical on IC engine. First is the piston speed. Vp is equals to 2ln divided by 60. And Vp is in meter per second, where capital L is length of stroke or stroke length in meter, and capital N is equals to engine speed in revolution per minute, that is RPM. Energy supplied to engine, Q fuel, that is equals to mass of fuel in kilogram per second multiply by CV, that is calorific value of fuel in kilojoule per kg. And on calculation, we are going to get energy supplied to engine, that is Q fuel in kilojoule per second, that is kilowatt. Now mass of fuel should be in kilogram per second. If they have given us the mass of fuel used per hour, that is in kilogram per hour, that is to be converted into kilogram per second. So mass of fuel in kilogram per second, that is equals to mass of fuel used per hour in kilogram per hour divided by 3600. Sometimes instead of mass of fuel used given, the volume of fuel used is given, either in meter cube per second or it is in liter per second. So the same is to be converted into kilogram per second to calculate the energy supplied to engine. So mass of fuel in kilogram per second, that is equals to volume of fuel used in meter cube per second multiply by specific gravity of fuel multiply by 1000. If the volume of fuel used is given in liter, then we can convert the liter into meter cube using the equation 1 liter is equals to 10 raised to minus 3 meter cube, or 1 meter cube is equals to 1000 liter. CV is calorific value of fuel in kilojoule per kg. Indicated power, IP. So IP can be calculated using the equation PM LAN divided by 60 multiply by number of cylinder, and the unit of the IP is in watt. Or in a simple form, it can be remembered as IP is equals to plan by 60 multiply by number of cylinder. Now PM is indicated mean effective pressure in Newton per meter square, that is Pascal, is equals to MEP or IMEP. So PM can be written as MEP or it is also written as IMEP. So here if we substitute the value of PM in Pascal, or that is Newton per meter square, we will get the IP in watt. If we substitute the value of PM, that is indicated mean effective pressure, in kilopascal, then we may get the IP in kilowatt. Sometimes PM is not given directly, so we have to calculate the indicated mean effective pressure using the equation PM is equals to spring scale, and the unit of the spring scale is Newton per meter square per centimeter multiply by area of indicator diagram in centimeter square divided by length of indicator diagram in centimeter. So using this equation, we are required to calculate PM first, and then using that PM, we can calculate the IP. Now the next one is the L. Now L we have already understood, that is capital L is equals to stroke length, that is in meter. Next one is the capital A, that is area of cylinder, or it is known as the area of piston. And it can be calculated using the equation pi by 4 d square, and it is in meter square. Now what is d here? So capital D is inside diameter of cylinder in meter, or it is outside diameter of piston in meter, or cylinder bore in meter. Now next is small n. So small n is number of power stroke per minute, and that can be equal to capital N by 2 for 4-stroke engine. So what is capital N? Capital N is nothing but the engine speed in RPM. Right? So small n is equals to capital N by 2 for 4-stroke engine, and small n is equals to capital N for 2-stroke engine. So if in numerical, if they have given you 2-stroke engine, then we can substitute the value of small n, that is equals to capital N. Now the last is the number of cylinder. So using this equation, we can calculate the IP. Now the brake power. Brake power in watt can be calculated using two equations. The first equation is brake power is equals to 2 pi nt by 60, and another equation is brake power is equals to PMB LAN by 60 multiplied by number of cylinder. So according to the data given in the numerical, we are required to use either first equation or second equation. So now let us study the parameter. The first parameter is 2 pi constant. N is the engine speed in RPM, that already we have studied. Capital T. So capital T is equals to brake torque in Newton into meter. So if we substitute the brake torque in Newton into meter, then we can get the brake power in watt. If it is in kilonewton into meter, brake power will be in kilowatt. Now next one is the PMB. So PMB is known as the brake mean effective pressure, and it is in Newton per meter square, that is Pascal. And it is also written as BMEP. If we substitute the value of brake mean effective pressure in Pascal, we may get the brake power in watt. If we substitute the brake mean effective pressure in kilopascal, that is kilonewton per meter square, then we may get the brake power in kilowatt. L, we have already studied. Area, pi by 4 d square. Small n, again recalling, small n is equals to capital N by 2 for 4-stroke engine, and small n is equals to capital N for 2-stroke engine. Sometimes brake torque is not given directly, so we have to calculate the brake torque using the other data given. So that to calculate the brake torque, we should use the equation brake torque in Newton into meter, that is equals to effective load on brake drum in Newton multiplied by effective radius of brake drum in meter. Now effective load. So effective load in Newton is equals to W minus S in Newton. Now what is W? W is load on brake drum in kilogram, and multiply by 9.81 to convert the kilogram into Newton. Capital S is equals to spring balance reading in kilogram multiply by 9.81 to convert it into the Newton. Sometimes they don't give the data for the S, spring balance reading. So we can neglect it and we can write down effective load N is equals to W. Clear? Sometimes they give you net load. So net load is nothing but the W minus S value. Effective radius of brake drum. So effective radius of brake drum is equals to diameter of brake drum plus diameter of rope divided by 2, and it is in meter. So D brake drum is equals to diameter of brake drum in meter, and D rope is equals to diameter of rope in meter. Sometimes they don't give the data for the D rope. So if they have not given us the data for the D rope, we can neglect it and we can use only the diameter of brake drum. So we can neglect the data whichever been not given. Friction power. So friction power is equals to IP minus BP, that is indicated power minus brake power. Mechanical efficiency. So the mechanical efficiency, that is equals to brake power divided by indicated power multiplied by 1000. So the unit of brake power and indicated power should be the same. Thermal efficiency. So there are two types of thermal efficiency that we can calculate: indicated thermal efficiency and brake thermal efficiency. Indicated thermal efficiency is equals to IP, indicated power in kilowatt, divided by energy supplied to engine in kilowatt multiplied by 100. So IP in kilowatt divided by mass of fuel in kilogram per second multiplied by calorific value of fuel in kilojoule per kg multiplied by 100. Brake thermal efficiency. So the brake thermal efficiency is equals to brake power in kilowatt divided by energy supplied to engine in kilowatt multiplied by 100. And therefore, brake thermal efficiency is equals to brake power in kilowatt divided by mass of fuel in kilogram per second multiplied by calorific value of fuel in kilojoule per kg multiplied by 100. Relative efficiency. So the relative efficiency is equals to indicated thermal efficiency divided by air standard efficiency multiplied by 100. Relative efficiency can also be written as brake thermal efficiency divided by air standard efficiency multiplied by 100. So air standard efficiency. So if the petrol engine, that is Otto cycle, is given, air standard efficiency can be given by the equation 1 minus T4 minus T1 divided by T3 minus T2. Or it can be given as 1 minus 1 upon R raised to gamma minus 1. Or it can be calculated using the equation 1 minus T1 by T2. If diesel engine is given, then air standard efficiency can be calculated using the equation for the diesel cycle that we have already studied in the chapter heat engine. Volumetric efficiency. So the volumetric efficiency for the petrol engine can be written as actual volume of air and petrol entered into the cylinder at atmospheric condition divided by swept volume multiplied by 100. And if it is a diesel engine, it can be written as actual volume of air entered into the cylinder at atmospheric condition divided by swept volume multiplied by 100. Specific fuel consumption. So it can be indicated specific fuel consumption and brake specific fuel consumption, that is ISFC and BSFC. ISFC in kilogram per kilowatt hour is equals to mass of fuel in kilogram per hour divided by IP in kilowatt. And BSFC, that is equals to mass of fuel in kilogram per hour divided by brake power in kilowatt. And the BSFC is in kilogram per kilowatt hour. Specific output. Specific output in kilowatt per meter square is equals to brake power in kilowatt divided by area in meter square. So using above equations, the numerical on IC engine can be solved. For any query, kindly comment in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.